So this is the price that I pay to have the solar running. Anyway, I was gonna check to see if anybody was on a 10 meter AM, but it's pretty impossible to even see what the hell's going on. It's cold in here. I have the heater on, and I'm also charging some batteries, so it is what it is. I don't think I'm probably putting out a whole ton of power here. Let me see here. It's 580 something watts, but there's more than that going in there because I have other stuff. Well, anyway, so I can either turn it off and, check the radio, or, work in between it or whatever, but, there's no getting around it. I think if you buy a little bit more expensive solar stuff, you might have less of a problem. I don't really know how the panels are with the microinverters on them. I think it's potentially could be a lot worse, because what really happens with the solar is that in the inverter there's switch mode stuff, unless you have like a low frequency inverter, and those are a little bit better. There are companies that make stuff on purpose that won't make noise, and then the rest of it they just don't care because it's made in China, and they don't have to conform to any kind of standards. So, but either you pay like 10 times the money, or you just deal with it. And ham radio is cool, but it's not like the end all be all, and like I need to have reliable backup power and things like that. And the idea originally was to supplement the power bill, but anyway, it's kind of not quite been like that. We have 30 solar panels ground mounted, and a couple of different battery systems, and it's not grid tied or anything like that, so it basically is completely off grid and only runs certain things. But don't worry, a heater draws plenty of power. Like a 1200 watt heater is exactly as it is implied. It draws 1200 watts at 120 volts. That's about 8 to 12 amps out of the wall. And in order to produce 8 to 12 amps or 1200 watts, you're going to need over 1200 watts of solar to do that, and that comes into the inverter and all that, and the charge controllers you're going to lose. So I run a 24 volt system, but most people that are really, really serious run like 48 volt. A lot of the professionally installed stuff doesn't even do that anymore. They don't even, they have like N-phase inverters on all the panels, and there's no DC wiring anymore because it's all, converted at the panel level. And basically you have, your Romex running through conduit, literally. So basically, that's a little bit different. But those are more for, grid tied systems and stuff like that. It gets a lot more complicated when you have battery power. But the stuff all makes noise, all of it makes noise. And some is better than others. And I've put capacitors on the inputs of, the solar side, and I didn't notice any difference when I did it on the battery side, but that's because the battery's inside here. Solar panels have long runs that go outside, which act as antennas. So, but when you have, 30, 40, 50, 60 feet of, PV wire going to, 10 panels here, 10 panels there, I mean, they act as radiators, especially if they're underneath your antenna. So, there's only so much that you can do about it if you have dirty equipment, And these particular ones, I have 3 different things going on here. I've got, these are just 40 amp charge controllers at 24 volts. They're capable of 1,000 watts a piece. And then this one here is a 3,000 watt inverter, and I don't think there's very many panels on it. I just have it for a backup in case that I need to run more than one inverter. So that's 3,000 watts. And then this one up here is 2.4, so 2,400 watts. It's a little bit less, but it's cleaner. This one here is really dirty and it makes a lot of noise. This one here, and you got all this other stuff on it. It's an MPP solar, HVL 2424. You can take 2 of them if you buy another one and put them together and have 240 volts. I don't really have anything that runs on 240 volts that I need to run. If I was going to tie it to the house with a transfer switch, then I would definitely be wanting to do that for sure. I honestly would like to get rid of all of this and get the 6.5 kW all-in-one inverter, the one that can actually run batteryless, and do something else with these. Are these batteries here? I know this looks like a mess. Anyway, these batteries here have been actually doing quite well. They do not like to be in pairs for some reason, so when you 3 them up, they seem to balance. I don't know, I was having problems because you see like the green light on them. These two are identical. This one is basically the same thing. It's just a different manufacturer. I don't know how close it is, but they're all Group 24 deep cycle batteries. I've had a lot of trouble with the Walmart ones, like just not balancing. And I think that's going to kind of be like everything. So I used to have one of these meters on every single one. I can put it across the battery if I change how it is and read it at 24 volts. I'm looking at this individual battery right here, actually. I can move it around, but I just try to see. So we can see right here the current going in it, and watts and all that bull. And it gives some estimated amp hour capacity, which is erroneous, trust me. But I can run the heater quite a bit in the winter, believe it or not. But yeah, this whole thing's kind of an experimental mess. So that's why I want to just get rid of all this and go to one. And then also the MPP solar versions are cleaner than this is a PAL MR, an older version. And this one here in particular is not real good, even though it's 3,000 watt. It only has a 40 amp charge controller, which is the equivalent of one of these. So you have a 3,000 watt inverter, but you only have a 1,000 watt charge controller, which means that its intention wasn't to run continuously, because you could never ever keep up with 3,000 watts when you only have 1,000 watts of input. It just won't happen. So and these are around the $500 mark, or 400 something. And I don't know that they're really worth that kind of money. This other one here is $700, and you can set a timer and all that on this and tell it when to turn on and when to turn off, and it can start your generator. And you can see I have the parallel board in this one. This one here can't do any of that kind of stuff. It can start a generator. It's got a generator set of dry contacts, and it can do some other stuff. There's USB on it, but It's very strange. And then a lot of these, they have like a really weird like floating ground. As you see like right here, I don't know. And so if you like go ahead and power up like a power strip, you'll get like a, you know, a not protected indicator light. On any of the ones I've ever used, they all seem to do that. And I've checked the output on them with an oscilloscope, and they're not too bad. You know, I mean, they're fairly clean. I had one of those reliable branded inverters, and that thing was actually a filthy pig. It was just like really nasty. You know, the only thing worse than that would be like a Harbor Freight inverter that's a modified, you know, sine wave. And these are good for that part. So, but if you run a modified sine wave, it is super hard on certain stuff, and you know, easily burn out an air conditioner or something like that just because the motor doesn't like the square wave part of it. But you got something like this heater, it doesn't care what kind of power you're giving it. But you know, I mean, it's something to keep in mind if you're going to dip and dabble with solar and you have sensitive electronics. You know, but I don't power any of my radios off of this or anything like that. I do have some extra 250 watt or 260 watt LG panels that aren't even hooked up. And I did think about, I have another one of these charge controllers, and I did think about just going ahead and getting some more wire, because you need this stuff here. This is really, really thick stuff. It's like a 10 gauge wire in a double shielded, you know, weatherproof, sunproof, UV proof, you know, deal. I thought about doing that and putting like down over here, you know, a 12 volt system just to have 12 volt power. But I mean, I don't know if I want to do that or not. So anyway, let me turn this off and show you guys. So first, let's turn off the inverter. Okay, so the inverter, it'll stay on for a second, and then you kind of hear it go click. I mean, the inverter itself actually like makes a really big difference. I mean, you see how much of a difference that is. So, and then you see it shoots out some spikes, and then it kind of goes into some other type of mode. And because what happens is, as the load is removed, the frequency of the maximum power point tracking system, the MPPT, it changes. And so then now it does like different things. So it'll come and go, you know, it'll change, you know, and also it's quite possible if I did move this into the house or something that it might actually, you know, behave better. So we have circuit breakers, and these are, I don't remember what these ones are, 30? 32, I think. I don't know. I can't read them. Yeah, I can't even remember anything anymore. This one's a 63, C63A. No, these are all 63s. So basically, okay, so if you have a 40 amp charge controller and you just put a 63 amp, you know, deal, if something surges, it'll pop. But you don't want to put a 40 on a 40 amp charge controller. These things will actually do 40. I've seen them do it before under a load. So, I really, really don't like these particular brand of ones. The wires will pull out really easily. You kind of have to solder the end of the wires because the clamps are really terrible. They're just junk. You see right here, it's hanging out. I think it might have just been stripped back too far on that one, but this one here came from Santan Solar. I don't know what kind of brand it is, but this is what they were selling at the time. And these have the magnetic thing inside of them to suppress any DC sparks. When you get a spark with DC, it will not extinguish. It will literally just keep arcing and catch on fire. So flipping a switch on a regular AC circuit breaker can literally cause a fire. So the reason is because we're looking at a voltage of like 70 volts or something like that. So you see we still have some noise. Okay. Now, and this is off is green, on is red. It's really stupid. Now, we will have these spikes until the actual unit itself decides to go to sleep. And once it does, then these ones will disappear. Now, if it was just this, I probably could just work around it because I can see where they're at. You hear it just clicked. And there does appear to be a small amount of noise further up in the band. The other unit does not have a circuit breaker in it. This one here, this is like 2 panels. It's just a trickle charge. It's on a 12 gauge cord. So what we do is we just undo it. And then once it decides to shut down, the only thing that's going to be doing anything is the charge controllers down on the bottom still have 24 volts going to them. So technically they're still awake. But to me, it looks like the rest of the noise is completely gone. So we know all that noise is, every bit of it is from this thing. Wow. Strong signals. There's a lot of people on there. It's like some kind of contest. They're always like right on top of each other. It makes it like really hard to tell. No, I don't like it when the waterfall moves like that. I like it. And then we could also go in.
Ticket contest, November 4, Zulu, Zulu. Hello, Juliet 6 Tango Sugar X-Ray, Don, Tennessee.
Where am I? So.
Thanks, November 4, Zulu, Zulu.
Okay, we're at fixed.
A7 Lima Radio, Don.
See how
Tennessee.
I can't even see where I'm at?
Thanks, November 4, Zulu, Zulu. Whiskey 4 Romeo X-Ray, Don, Tennessee. Hey, Don, this is Steve in Southeast Florida. Okay, very good. Thank you, Steve. New one.
See, we're not even looking.
November 4, Zulu, in Tennessee.
So now I can see my signals, but like it's not looking at.
Roger, Mac. Good job. 73. Thanks, November 4, Zulu, Zulu.
It looks at like a part of the band edge.
W6 Echo Oscar, Don, Tennessee.
It's like, where is it? Well, now we can see where he's at, but I don't like it when it's in center. They put it on cursor. It's a little better. Now fixed is wherever this thing decides to be.
November 4th.
So basically, we're looking at 2800 to 28100 because our span is that. So really, if I want to look at the entire band, I need to be at 1000, and then I can see the part of the band I want to see, but I'm seeing all this bottom crap that I don't want to be at. And from what I can tell, Yaesu will not let you change your edges of the scope. You're just stuck with whatever it wants to look at. And so you get two choices. You can have it either center, where you're always centered where you're at and you don't have to worry about it, but the band will trail as you tune through it, you know. So as you're trying to approach a signal, it's all so you can't even see it. So I prefer it to be a waterfall that doesn't move, and I tune up to it. So, you know, then I can, you know, look and see, okay, here's a signal here. Let's tune to this signal. I can look at it. I can bring my marker up to the edge of the sideband, and then I get a pretty good idea of where they're at on the frequency, you know. But that's really hard to do when you're in center mode. Now, fixed mode, like I said, that's fine, but you're looking at the entire damn thing. So, now in cursor mode, what happens is when you get to the end of it, and then it starts to scroll over to adjust. So, that's actually probably the best mode. What the hell frequency? Anyway, I'm about to go outside and set up portable, because to me this is just not that interesting. And I'm sure with the contest I could probably make a bunch of portable contacts.